Yeah, students, now we will see a few more problems of this kind. Projections of solids, special cases. So, hexagonal pyramid of base height 25 mm and axis length 55 mm rests on HP on one of its base corners in such a way that two of its base edges is equally inclined to HP. Draw its projections when the solid axis is inclined at 40 degrees to VP and parallel to HP. It is a very similar problem what we have seen in earlier cases. It is hexagonal pyramid. Now it should be connected with the O with thick lines. So this is this is the initial top view. Now reproduce this top view, right? Reproduce this top view here, right? And this is the tilted top view, tilted top view. Mark the points. So this is your F, and this is A, B, this is C, and here you get a D, and this is O, right? So connect all the outermost points with thick lines, and CB are here, right? They are very near to XY reference line, so they are invisible points. So connect D to C dotted line, and E to O is a visible edge. E to O, F to O are visible edges, and draw the dotted line, and C to B dotted line, B to A also dotted line, C to O dotted line, B to O dotted line. So this is the final front view. So next problem, a square pyramid of base at 30 mm and axis length 60 mm rests on the HP on one of its base edges and has one of its lateral surface on VP, right? So lateral surface on VP, so it is actually attached to VP, right? So you have to draw the final top view, tilted top view on the XY reference line. When the solid axis parallel to HP, draw its projections. So it is a square pyramid, right? It is square pyramid and axis length 60 mm rests on HP on its base edge, right? It is resting on base edge only. It is resting on base edge. So it is pyramid. So you should draw a line on XY reference line. So this is the initial orientation. So this is a pyramid. Draw the pyramid. Draw the front top view of the pyramid. Simple front top view. Now it is resting on VP, right, on lateral surface. So this is the lateral surface. So lateral surface here CBO, right? This is the slant surface or lateral surface. This is on lying on VP, right? So now CBO line you draw on the XY reference line, right? CBO line you draw on XY reference line and reproduce this view here, right? Reproduce this view here, right? So this is the small exercise you have to do, right? So now it is very simple. Draw this line on XY reference line and measure this distance, draw an arc, and measure this distance, draw an arc, right, from O. Then the intersecting point will become your D1A1, right? D1A1. Now you project onto front view. So this is O, and you get all the points, right? All the points. So this is the final front view. This is your final front view. Sorry, this is your final front view. So next is a pentagonal pyramid of base side 30 mm and axis length 55 mm rests on HP on lateral surface, right? Rests on VP on one of its lateral surface. So it is also very similar to earlier problem, right? Draw the lateral surface. So here this is the lateral face, right? One of the lateral face, it is resting on lateral face. So this is ODE, right? It is ODE. On ODE it is resting. So ODC it is resting. Now reproduce this view here, right? And then draw its final front view, right? Draw its final front view. So draw its final front view. Now A is here, A is away from XY reference line. So E to A should be thick line, A to B should be thick line, A to O should be thick line, and D to O, C to O should be dotted line, right? So this is the final front view. So it is resting on DCO, right? It is resting on DCO on VP. In the earlier problem also, it is resting on the slant slant face on VP. So similar kind of problem, both are very similar. So 49th problem, a hexagonal pyramid of base side 30 mm and axis length 60 mm rests on the VP on one of its triangular faces with its axis parallel to HP. Draw its projections. So it is also very similar, right? It rests on VP on one of its triangular face, right? It is also slant face, triangular face, lateral face, all are same. So draw the lateral face here. So this is hexagonal pyramid, and this is the lateral face. This is lateral face, right? DCO. It will be lying on DCO now, right? So draw the front view on top view, right? So now DCO, this DCO you draw here and reproduce this view, top view here, right? Top view here, right? So DCO you draw here, or you can draw this side also, no problem. O here, DC, O here, DC here, and then you can project it. Anyway you can do it. Both are correct only. So this is the final front view. So just project all the points, mark all the points. This is C, B, A, right? F. Here it is E, and this is D, and this is O1 dash, right? These are the points you are getting in front view, and mark with all outermost points you connect with thick line, right? No change in that rule. And now F is here, A is here. So EF should be thick line, FA should be thick line, A to B should be thick line, F to O and D to O a dotted line, and C to O a dotted line, F to O a thick line, A to O a thick line. So this is the final front view. So very similar problem, all are similar kind of problems. So 50th problem, a square pyramid of base side 30 mm and axis length 60 mm rests on the HP on one of its base corner and has one of its lateral edges on VP. In the earlier case, the lateral slant edges, slant face, only faces are on VP, whereas here the edge is on VP. So on right side, right, you make sure that you are getting a corner, right? In earlier case, you have drawn edge, whereas here it is corner. You should get a corner. It is a square pyramid. That's why you have a diamond shape of pyramid. So A, B, C, D, E, and this is the corner. Now it is resting on corner. In earlier case we have seen slant face and lateral face, and reproduce this, right? It is resting on OC. So this is OC, and reproduce this view here and projectors and mark the points, remaining points here. So this is C, and this is this is your B, right? This is B, this is A, and you will get A, B. So here this is D, right? This is D point. So mark the points, and all should be connected. A is here, and A to O should be thick line. A to O should be thick line. So this is the final front view. Final front view. A cone. It is a cone of base diameter 50 mm and axis length 60 mm, has one of its generators on VP with a solid axis parallel to and 40 mm above the HP. Draw its projections. So here it is resting on one of its generators on VP. It means that it is a corner, right? It is a corner, so it is a point, right? It is a point. So on this point it is going to rest. GO generator, it is going to rest on VP, right? It is going to rest on VP. So GO, and this is GO, right? This is GO. Reproduce this view here, right? Mark all other points and project it onto front view. So you have more number of lines, thin lines, so no need to worry about lines. So this point is your G point, G1 dash. Now remaining points you mark along the projectors. So this is O dash, and all outermost points should be connected with a thick line, and O, it should be G. Now this should be A, right? It should be visible. It should be visible arc, visible arc. Now the points nearer to these points are visible generators. These points are visible generators, and this is the final front view of this cone, right? 52 52nd problem, right? It is a pentagonal pyramid of base side 35 mm and axis length 60 mm, has one of its lateral edges on VP. So one lateral edge means you have to draw the corner on right side above XY reference line, and the solid axis is parallel to HP, parallel to HP. So this is how you should draw. It is the corner, and now draw the simple top view for this, and it is resting on this OC, on OC edge, right? OC edge, and reproduce that view here, right? And get all the points. So this is C dash, and this is O dash, right? You connect all outermost points with thick lines. So EA is here, right? EA is away from XY reference line. Both are visible points, and draw DE thick line, E to A thick line, A to B thick line, and E to O thick line, A to O thick line, and C is nearer to here. It is on VP, and C to O dotted line, right? So this is the final front view. 53rd problem. A hexagonal pyramid of base side 30 mm and axis length 60 mm has one of its lateral edge on VP, and the solid axis is parallel to HP. Draw its projections. So here it is also resting on lateral edge, right? So on right hand side you get a point and draw the hexagon. It is hexagon. Now this is the point. It is a pyramid only, and draw the pyramid lines. It is apex, slant edges should be drawn, and this is OD, right? AO, and now you draw the you reproduce this view here, right? You reproduce this view here, and draw the projectors, mark the points. So this is D, and here you get C. So this is B, and mark other points, and this is O. All outermost points you connect with thick lines, and A is visible, and A to F should be thick line, A to B thick line, A to O thick line, D to O a dotted line, right? D to O a dotted line, and E to O a dotted line, C to O a dotted line. So this is the final front view of this problem. So 54th problem, a tetrahedron of edges 50 mm rests on one of its edges on the VP. One of the face containing the resting edge is inclined at 30 degrees to VP. So here the true shape should be drawn on VP. Draw its projections of the tetrahedron when the resting edge is normal to the HP. Right? When the resting edge is normal to HP, that is, it is perpendicular to HP. So this is how you should draw the tetrahedron. So this is the resting edge. One of the faces containing the resting edge is inclined at 30 degrees to VP. So this is the resting edge, right? This is the resting edge, and it is one of its faces containing the resting edge is 30 degrees to VP. So this is C dash C1 B1, and O, right? C1, B1 and O1 is the is making 30 degrees to VP, right? 30 degrees to VP, and draw the final projections. It is a uh, simple view only. So this is the parallel edge, right? It is parallel to HP. That is why this should be measured 50 mm, right? This is 50 mm. So height is normally not given in the problem, tetrahedron problem. Now remaining points you mark and get the final front view. So this is CB and AO, right? AO should be marked. So AO is a thick line. AO is a thick line, and CB is a dotted line. CB is a dotted line. So this is the final projection of this tetrahedron. So next is yeah, students, next we'll see another problem. A square pyramid of base height 30 mm and axis length 60 mm is suspended by means of a string. So it is suspended by string. So it is a hanged problem. So the solid is hanged by string, right, from one of its base corners. So you should make sure that the corner is drawn on either right side or left side. In this case, with its axis parallel to VP, obviously the axis will be inclined to HP. Draw its projections. So this is the square pyramid, and you make sure that either this side or this side you should have a corner, right? So anyway you can hang it A B C D O and draw it simple front view, right? It is simple front view. So there is no change in simple position. So now you have to do this small calculation. So from base, the CG, center of gravity, will be lying at a height of one fourth of solid height, right? So from base, you have to measure, you have to calculate this 60 by 4, that is 15 mm. From base at 15 mm, you will have CG, right? CG. Now this CG can be connected to A dash, or it can be connected to C dash. Anyway is fine. So I am connecting to A dash. So this is the CG. So this line, when you hang it, it will be a perfect vertical line, right? So with reference to that, we have to proceed in this problem. So that is very, very important. And CGA, A to CG line will be a perfect vertical line. So first draw that line and then reproduce this view with respect to this line. That is the simple exercise, and you have to do, and it will be very easy also. I will tell you. Now my pyramid is suspended from the corner A, right? So this is the line, right? A to CG. So this is A1 dash and this is CG dash, right? And now with reference to this, right, from CG you measure this distance and cut a arc, right? From CG you cut one arc, and from A measure this distance, cut another arc. From A measure this distance and cut another arc. You will get the point O dash. So this is O dash, and from O dash to CG it will be a line. Now to this line you can set the drafter at 90 degrees, right? So perpendicular to this you can set the drafter, and you can draw another line, right, of length, this base length, right? This base length can be drawn, and you can complete the remaining line, right? So this is a thick line, right? This is a thick line. Now I have reproduced this view here. You have to do it very carefully. Suppose if you join CG to C, it will be in this direction. So that way also you can do. That is also correct. You will get full marks. So this is my final point. The final step is as usual. There is no change. It is very simple. And mark all the points. Now the outermost point should be connected with thick lines, and A is here. It is the outermost point. A is connected to O with thick line, and A is connected to B with thick line, and A is connected to O with thick line, and C is here. C to O is an invisible line, and it should be connected. C to O should be drawn with the dotted line, right? So from anyhow from here to here it will be a thick line, right? Already you have a thick line and you can see the dotted line from here to here only. So this is the hanging problem. Same procedure you can adapt to even cylinder, even cone, prism, whatever may be the solid, right? You have to adapt. Suppose if you have cylinder and a prism, the CG will be at the 1 by 2, right? 1 by 2 into h. With that you can calculate, right? For cone also it is 1 by 4th of h from base. So this is how you can do this problem. So we will see another problem of this kind. A pentagonal pyramid of base height 25 mm and axis 60 mm height is suspended from a string attached to one corner of the base of the pyramid. The string is held such that the apex of the pyramid is just touching HP. Draw the axis of the pyramid is parallel to VP. Draw the projections of the pyramid. So that is the trick given here. The apex should touch the HP, that is XY reference line. So that you have to ensure and you have to satisfy that condition. So this is XY reference line, and you can have a corner here, right? With this corner I am going to hang this solid and draw the simple front view, measure this CG is at 1/4 of height from base, right? You measure CG and mark a line. From D I am going to suspend this, right? So this is D, CG to D you draw a thick thin line, right? Now this line should be drawn, right, in such a way that apex should be touching this XY reference line, right? So now you can do like this, right? So this step, right, this step can be done separately, right, without any XY reference line, and you can do, otherwise you can do like this also. You have this line, right? You have this reference line. Now to this line, right, you set the drafter parallel to this line, right? Parallel to this line. It will be very simple if you follow this procedure. Now you draw a thin line, right? Now you draw a thin line 90 degrees to this line. Students, when you draw the thin line, that should touch this O, apex, right? It is only for reference. You are not going to use that line, or you are not going to keep that line as thick line. It is a thin line, it has no meaning, but that is useful to reproduce here, right? So set the drafter one scale parallel to this, and now touching this point you draw a perpendicular line to this CGD line, right? Once you do this, now this is your reference line, it is touching O now, right? Now with reference to this line you can measure each and every point, right? You can measure each and every point of this view, and you can reproduce with reference to this line, right? You measure from this line and mark from this line. Simple, you can easily reproduce. So that way you can proceed, and this is the line, this is the line. So if you have a line already here, you can measure the distance, right, from here to here. So that is nothing but this distance, right, that distance. And now this is CG, and from D, right, from D, right, you can measure O distance and cut arc. Now you can draw this line, and through CG and apex you can draw a line, and you can measure this distance, and you can cut arc, and or you can set the drafter at 90 degrees and you can draw this line. Now you can connect it. Now you have successfully reproduced this view here, right, this view here, right? So now there is a line, another line, it is OCE, right? OCE. Now the remaining procedure is same. You project it and get the remaining points, right? So this is A, and this is B, and this is C, and this is D, and this is E, right? And this is apex. Now connect it with thick lines, outer lines, and D is outermost point, so that is visible point. and A and B are nearer to XY reference line, and A to O should be dotted line, B to O should be dotted line, and E to D thick line, D to C thick line, and D to O also thick line. So this is the final top view, right? So this is the final top view, and we will see few more problems. So next problem is hexagonal pyramid. It is a hexagonal pyramid. Our base at 30 mm and axis length 60 mm is suspended by means of a string from one of its base corners with its axis parallel to VP. Draw its projections, right? Draw its projections. So it is very similar problem. Only it is also very easy problem. It is not touching any ground, right? So it is suspended, freely suspended, that's all. So you can easily do this, right? So this is the hexagon, and now it is suspended through D, right? So draw simple front view and top view. It is very similar problem, and my CG is at 15 mm from base. Now CG and D, so this should be drawn here, right? As we did earlier, we can reproduce this view with reference to this, right? So now reproduce that view, and you draw the final top view. So this is D1, and this is C1, it is B1, it is A1, you have F1 and E1, this is O1, and connect all outermost points with thick lines, and E to O should be thick line, dotted line, C to O should be dotted line, and A to B, F to A to B should be thick line, and B to O should be B to O should be D to O should be dotted line, right? D to O should be dotted line, A to O should be thick line. So these are the lines you have to consider and draw. So this is your 57th problem. We will see one more problem. A hexagonal prism, right, base height 25 mm and axis length of 50 mm is suspended freely by means of a string from one of its base corners with its axis parallel to VP. So it is prism. So prism, the CG will be at half height of the prism from its base, right? So you can draw this simple front view on top view, right? From any corner you can suspend it. So this is how you should draw, right? This is freely suspended problem, right? It is half, it is exactly half, right? You draw this line, it is like a diagonal vertical, right? It is very similar to diagonal vertical. That way you can consider and complete this problem. Already we have seen diagonal vertical, so it is very similar to diagonal vertical, and this is how you should do the problem, and complete all the projections, right? Complete all the projections, and this is the thick line. All outermost points should be connected with thick line, right? And this is fourth point is here, F24, right? F24, F2A, right? F2A should be connected with thick line, A21 should be connected with thick line, 425 dotted line, 423 dotted line, right? And you will have a dotted line here, right? So this is the final projection of this hexagonal prism. Even though it is freely suspended by string, right? The exactly the midpoint, right? This is the CG, so it will become diagonal vertical, right? In same fashion you can do this problem, right? So there ends the projections of solids. We have seen a variety of projections of solid problems, and still if you have any doubt you can always approach me, students. Next session we will start unit number 4, right? We are completing unit 3 here. and please go through all the problems so that you can easily solve any problem in the exam, right? You please practice as many as possible. Thank you students.